The expansion device function is to reduce the pressure from condenser pressure to an evaporator pressure. Expansion devices. There are basically 7 types of refrigerant expansion devices. These are manual expansion valves, general valves. So for regulating the flow, you will get a less pressure flow. Capillary tubes, orifice, constant pressure or automatic expansion valve, thermostatic expansion valve, float type expansion valve, high side float valve, low side float valve, electronic expansion valve. So there are different types of expansion devices. Few of them were discussed here. Capillary tube. A capillary tube is a long, narrow tube of constant diameter. The word capillary is a misnomer since the surface tension is not important in refrigeration application of capillary tubes. Typical tube diameters of refrigerant capillary tubes range from 0.5 mm to 3 mm, and length ranges from 1 meter to 6 meter. A capillary tube is a long, narrow tube of constant diameter. The word capillary is a misnomer since surface tension is not important in refrigeration application of capillary tubes. The same is getting repeated here. Advantages and disadvantages of capillary tube. Some of the advantages of capillary tube are: first one, it is inexpensive. It does not have any moving parts, hence it does not require maintenance. Capillary tube provides an open connection between condenser and the evaporator. Hence, during off-cycle, pressure equalization occurs between condenser and evaporator. This reduces the starting torque requirement of the motor since the motor starts with same pressure on the two sides of the compressor. Hence, a motor with low starting torque, squirrel cage induction motor, can be used. Ideal for hermetic compressor based systems which are critically charged and factory assembled. Some of disadvantages of the capillary tube are: it cannot be it cannot adjust itself to changing flow conditions in response to daily and seasonal variation in the ambient temperature and load. Hence, COP is usually low under off design conditions. It is susceptible to clogging because of nature bore of the tube. Hence, utmost care is required at the time of assembly. A filter dryer should be used ahead of the capillary to prevent entry of moisture or any solid particles. Now, an automatic expansion valve. An automatic expansion valve is also known as a constant pressure expansion valve, acts in such a manner so as to maintain a constant pressure and thereby a constant temperature in the evaporator. The schematic diagram of the valve is shown in figure. This figure consists of a different parts. You have adjustable spring, adjustable screw, diaphragm, orifice, flow up spring, and you have passages from condenser and passage to evaporator. You have a needle. That's it. The valve consists of an adjustment spring that can be adjusted to maintain the required temperature in the evaporator. This exerts force Fs on the top of the diaphragm. When these two forces are balanced, then the diaphragm will not move. So the level of the flow rate of the refrigerant is fixed because of that adjusting screw. Now, thermostatic expansion valve. The thermostatic expansion valve is the most versatile expansion valve and is most commonly used in refrigeration systems. Thermostatic expansion valve maintains a constant degree of superheat at the exit of evaporator. Hence, it is most effective for dry evaporators in preventing the slugging in the compressors, since it does not allow the liquid refrigerant to enter the compressor. The thermostatic expansion valve got very good advantage because a constant degree of superheat at the exit of evaporator. Hence, it is most effective for dry evaporators in preventing the slugging of the compressors, since it does not allow the liquid refrigerant to enter the compressor. Yes, we should not have a liquid refrigerant into a compressor. It is a disadvantage. So avoid it. To avoid that, we are using thermostatic expansion valve, TEV. See the figure. You have again adjustable screw, spring, needle stand, bellows. You have a capillary tube, feeler bulb, suction line, and you have liquid from condenser passage and liquid towards the evaporator. And we left with the devices in evaporator. Of course, the thermostatic expansion, while it functions like an a most suggestible expansion device, where because it avoids the liquid refrigerant to enter into compressor. It means it regulates properly it expansion itself and allows the evaporator for proper evaporation process. Once the refrigerant get properly evaporated, the refrigerant properly evaporated, then it will get so that liquid, so there won't be any liquid refrigerant entering into the compressor. Now coming to evaporators, an evaporator function, the evaporator function is, it functions as a heat exchanger. It absorbs heat from the evaporator space, refrigerated area, and converts the liquid refrigerant into a vapor. It converts the liquid refrigerant into a vapor. Coming to the types of evaporators. In an evaporator, the refrigerant boils. Actually, an evaporator like condenser is also a heat exchanger. In an evaporator, the refrigerant boils or evaporates, and in doing so absorbs heat from the substance being refrigerated. The name evaporator refers to the evaporation process occurring in the heat exchanger. Heat exchanger, natural and forced convection type. The evaporator may be classified as natural convection type or forced convection type. In forced convection type, a fan or a pump is used to circulate the fluid being refrigerated and make it flow over the heat transfer surface, which is cooled by evaporation of refrigerant. In natural convection type, the fluid being cooled flows due to natural convection currents rising out of density difference caused by temperature difference. The refrigerant boils inside the tubes and evaporator is located at the top. The temperature of fluid will which is cooled by it decreases and its density increases. It moves downwards due to its higher density, and the warm fluid rises up to replace it. And there are different types of evaporators. Flooded evaporators, you have different passage of tubules, and you have a shell and towards compressor, and you have a float. So everything is to manage a proper conversion of a liquid refrigerant into a vapor. A flooded type shell and tube evaporator. A flooded type of shell and a tube type liquid chiller, where the liquid to be chilled flows through the tubes in double pass, just like that in shell and tube condenser. The refrigerant is fed through a float valve which maintains a constant level of liquid refrigerant in the shell. This is done to maintain liquid refrigerant level below the top of the shell so that liquid droplets settle down due to gravity and are not carried by the vapor leaving the shell. If the shell is completely filled with tubes, then a surge drum is provided after the evaporator to collect the liquid refrigerant. And the last example is shell and tube flooded type evaporator. We have a shell here, and same the tubules and the passage of the refrigerant from one side, and it comes out through the other exit, and thereby we complete our third unit with different parts and the types of components of the refrigeration system.